Okay guys, let's now review chapter 9, and I'll just do some of these problems here from the first assignment, which is on pages 526 and 527. So let's look at number 8 to begin. Sprinkler system on a farm rotates 140 degrees and sprays water up to 35 meters. Okay, so first we want to draw a picture of what's going on here in this situation. Okay. Okay, and we can always just set it up here as we would a typical, say, trig, starting on the positive x-axis, and then we're going to rotate 90 plus another 50 here to get to our 140, okay? And I'm just going to extend that, and remember, if our radius here was 35 meters, and we move 140 degrees, but again, we have to convert degrees to radians when we're using arc length or area of a sector, okay? So 140 times pi over 180. Seven pi over 9, 7 pi 9ths. Okay, I divided them each by 20. 20 went into each, and I'm left with 7 pi over 9. Okay, all right, and then our formula here is area of a sector, which would be, again, let me fill in the space that this sprinkler is watering here. 1/2 r squared theta. And r is our radius, and remember, if this is our center point, center to the edge is 35 meters. (35 squared) times theta of 7 pi 9ths. Okay, so I'm going to pause real quick and go get my... Okay, and then of course we do 35 squared, then divide that in 2, multiply by 7 times 3.14159, that's pi, and then divided by 9. And that's approximately 1497 meters squared. Area equals 1497 meters squared. So the area of this sector here, all the shaded area, all the area that it would water, is 1497 square meters. Okay, and that's with the radius of 35 and moving an arc length of 140 degrees, remember? But remember, we have to convert these to radians, so we did that first to 7 pi 9ths, and then it's just a matter of plug in, right? And remember, for, say, arc length, that would be S equals R theta, if we were working an arc length problem, perhaps, okay? Okay, but remember, our radius has to be in, I'm sorry, theta has to be in radians, okay? And then a radius here, okay? Okay, so that should take care of number 8. Let's look at another one. Okay, guys, let's look now at number 14 here, sine of 13 pi 6. Remember, start with your initial side, and then we're going to move in the clockwise direction because it's positive here. And notice 13 pi 6 is greater than 2 pi, right? That would be 12 pi 6 or 2 pi. And then I'm going to go one more pi 6th. And I'm going to go ahead and then draw my terminal side, okay? And then I'm going to draw a line down here to my x-axis, a right triangle there, okay? And I know that this is essentially the same as the sine of pi 6th. I just took out one revolution, right? And pi 6, remember, is the equivalent of a 30. So 30 degrees. And then I say short side, long side. Now, if you still want to use your old triangles in these situations, of course you can. Once you're here, you could always just make that 2, 1, and root 3 for a 30. And remember, the 30 is the same as the pi sixth, okay? Okay, so, and remember, the ratios come out to be the same, right? So if I then said the sine of that, here on my unit circle, remember the radius is 1, so sine corresponds to y, so sine of 13 pi sixths is a half. Or if I did it with this triangle, sine equals opposite over hypotenuse, sine of 13 pi sixths, which is the same as sine of pi sixth, because that would just take out one revolution, opposite over hypotenuse. They come out to be the same, a half. So whether, once you draw your revolutions and where it ends up and you draw that triangle, you can use the original triangle if you like and construct it, or of course you can use the unit circle one and construct it. And really, it's a personal preference issue at that point. Just choose which one you like best, okay? So the sine of 13 pi sixths, which is the same as the sine of pi sixths, equals 1/2. Okay, great. Let's look at another one. Okay, let's look now at number 18 here. G of x equals 1/4 cosine of 4x. Again, start with your amplitude. The absolute value of a fourth is a fourth. And then let's determine our period, which again is 2 pi over b, and of course b is here in front of x, so 2 pi over 4 is pi halves. Okay, and then we can just go about graphing it. Pi halves is where it ends, starts at 0. Remember, for sine and cosine, it's going to have an amplitude of a fourth. It's going to go up a fourth and down to negative a fourth. And remember, we take the period and we divide it in 4. Invert and multiply, pi eighths. So I know when I broke it into 4 equal sections, I'm going to add pi eighths each time. And then 0 plus pi eighths is pi eighths. Pi eighths plus pi eighths is pi fourths. Pi fourths plus pi eighths is going to be 3 pi eighths. And then finally 4 pi eighths, which is pi halves. Okay. And then if we say cosine, remember, starts at our amplitude, not at the midline. Remember, our x-axis would be our midline here. So we're going to start at the positive amplitude because it's positive 1/4. And then here it's going to go through our key locations. And it's going to do, again, our sinusoidal shape. And we could always add on another period if we wanted here. Pi halves plus another pi halves. I'm going to add to now my ending location whatever my period length is here of pi halves. 1 pi halves plus 1 pi halves is 2 pi halves, which is pi. And then remember, I could add pi eighths each time and find all these. Well, pi halves plus pi eighths, that would be 4 pi eighths plus pi eighths would be 5 pi eighths. And then I could keep adding pi eighths each time and get all my intermediates. And then again, it would just obey the same pattern here as before. Okay, so it's a cosine, so it starts at our amplitude and it's going to end here at our period of length of pi halves. And notice peak to peak is the length of one period, or trough to trough, and we can construct multiple periods if we want. Okay, so I hope these help you get started on the reviews. And at this point, we'll just start to be reviewing. Okay, so let's work on these reviews and make sure we've got trig down, because it'll all come back next year. Okay, thank you. And then remember, that's a vertical shrink of 1/4 and a horizontal shrink of 1/4. Okay. Remember, because this goes in as 1 over a, right? So that's actually a horizontal shrink. And remember, our period's usually 2 pi, and it shrank down here to pi halves, okay? The length of one period. So horizontal shrink of 1/4 and a vertical shrink of 1/4. Okay, thank you.